Welcome, agents. I'm your strategist, and today you are embarking on a highly classified mission. Your objective? To extract maximum marks from a hostile exam paper in 20 minutes or less. We are diving deep into the ultimate explainer for cracking the code on how Cambridge examiners actually grade those notoriously tricky questions on binary addition and overflow. Whether you are operating under syllabus code 0417, 0478, 2210, or 9618, the tactical strategy we are building today is your ultimate extraction tool. We are absolutely not just going to sit here and recite textbook facts. No, we are going to reverse engineer the very blueprint the examiners use to assess your logic. It's time to stop guessing and start executing with precision. To understand how to win, we first have to look at why students fail. I want to introduce you to two specific profiles. Let's call them Alex and Sam. Both are sitting in the exam hall, staring down the exact same 0478 computer science paper. Alex's strategy? The data dump. He overloads his answers with raw, unfiltered computer science facts. He has literally memorized the entire textbook, but there is zero analysis, no structure, and no link to the scenario. Then we have Sam. Sam's enemy is the clock. She rushes. The moment her eyes scan a familiar keyword, like binary, she goes into autopilot and completely misses the specific command word requirements of the actual question. They both walk out of that hall thinking they absolutely aced the mission, but a few months later, their papers come back absolutely covered in red ink. Why? Because the core problem here is that students like Alex and Sam often recognize a familiar vocabulary word, but then write an answer to a completely different question from the one that was actually set. It is a classic fatal trap. And today, we're making sure you never fall into it. To rescue those lost marks and guarantee a successful extraction, we are going to break this complex topic down into a structured 5-part blueprint. We'll cover the learning trap, the 3 layers of mastery, description versus explanation, why context is everything, and finally, your exam execution framework. Let's move. Section 1, the learning trap. Let's take a look at the massive difference between memorizing a vocabulary list and building actual, usable connections. Think about binary addition and overflow for a second. In the real world, it is a mathematical solution to a very real digital problem, not just some neat little math trick you do on paper. A strong mark-winning response begins by understanding the digital problem, identifying the exact concept involved, and then linking that concept directly to the style of explanation the examiner is hunting for. This is where top-tier students use the PEL framework: point, evidence, explanation, link. The crucial takeaway is that students usually retain this topic much better when they understand the digital problem it solves, rather than just treating it as a dry vocabulary list. It's a highly connected structure. You have to know exactly why an 8-bit register crashing actually matters in the real world. If you just define the word without showing the consequence, you are leaving marks on the table. Surface features are designed to distract you from the core mechanism, leading to totally avoidable mark losses. Look at these traps. These are the exact landmines Alex and Sam stepped on. Recognizing a keyword like overflow, but totally ignoring the examiner's command word, like evaluate, means you end up writing facts in a random, disconnected order. You are essentially handing the examiner pieces of a jigsaw puzzle without putting them together. We need to upgrade your extraction strategy by structuring your points, evidence, explanations, and links properly. But hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you'll want this intel every single week. Moving into Section 2, the 3 layers of mastery. Let's decode the exact methodology top teachers use to build your understanding and transform those red marks into green check marks. You might honestly think you know a topic inside out after hitting these simple or technical layers. You might know that an overflow error happens when a number gets too big. Cool, that's step 1. Step 2 is upgrading your vocabulary, knowing that a standard 8-bit register can only hold a maximum value of 255, so adding a 1 to that generates a 9th bit, causing an overflow error. Getting better, but listen carefully. True mastery only happens when you can express it in that 3rd layer under intense exam pressure. Step 3 is shaping that technical knowledge into a concise, timed, PEL-structured response that explicitly states the consequence for the CPU. If Alex just gave us step 1, he gets 0 marks. If Sam rushes and gives step 2 without linking it to the specific system in the question, she loses the application marks. Could you write that step 3 answer right now under the pressure of a ticking clock? Section 3, description versus explanation.
Let's dive right into the critical distinction that examiners are actively searching for when they grade your papers.
Now, what's incredibly fascinating here is that the difference is profound, yet so many students miss it. If you only describe, your answer is safe, sure, but it is incredibly shallow. But on the flip side, if you only explain without naming and describing the concept first, you just sound confused and disorganized. Think back to our agents Alex and Sam. Alex described the binary addition perfectly. He did the math, but completely failed to explain the actual overflow consequence to the computer system. Sam explained that the system crashed, but she rushed and forgot to describe that the 9th bit was lost because the register was strictly limited to 8 bits. You absolutely must combine them to extract maximum marks. Description is your point and evidence. Explanation is your explanation and link. You need the whole PL structure.
Your computer science reasoning becomes remarkably stronger once you clearly define the boundaries between these key contrasting concepts. Why? Because these exact boundaries often control the entire direction of your exam answer. If a question asks about memory limitations causing an overflow, but you start answering using long-term storage terminology, your entire explanation instantly falls apart. Examiners love testing these contrasts. They want to see if you know the difference between validation and verification, or a compiler versus an interpreter, just as much as they want to see if you understand binary addition. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, Section 4. Context is everything. Let's lock in the fourth piece of this puzzle and see how grounding the theory in reality is a total game changer. Welcome to the interactive workshop phase of our mission. Okay, challenge 1, the data scan. I am putting 60 seconds on the mental clock right now. Look at this list of real-world applications. Mentally link the concept of a binary overflow error to just one of these systems, let's say banking. By repeatedly connecting the abstract idea of overflow to tangible, high-stakes technology like a banking system or industrial robotics, you remember the exact reason this concept even exists. An overflow error in a banking system doesn't just mean some invisible 9th bit fell off a register, it means a corrupted financial transaction or a wildly inaccurate account balance that could ruin someone's day. That real-world consequence is the crucial link in your PL-structured answer. Time for challenge 2. Find the flaw. I'm giving you another timer. Listen to this flawed sample paragraph. Binary overflow occurs when the result of an addition is greater than the maximum value the register can hold. This is bad for the computer. Did you spot the missing mark? This is bad for the computer is a completely generic 0-mark statement. So, challenge 3, speed writing. You have 30 seconds to rewrite that in your head. If the question is set in a manufacturing plant, your answer absolutely must stay inside that environment rather than floating off into abstraction. You must say something specific like, this overflow causes the industrial robotic arm to calculate the wrong coordinate data, resulting in a physical crash. Boom, maximum marks extracted. Section 5, the exam execution framework. Let's bring everything we've learned together into an actionable, highly disciplined system for the exam hall. This is your ultimate extraction system. This 4-step structure produces dramatically clearer, higher-scoring answers than simply writing facts in a random order or jumping backwards and forwards. First, command word decoding. Identify the demand. Is it evaluate, describe, or explain? Second, classify the concept. We know we are dealing with an 8-bit addition overflow. Third, PL framework application. Explain the mechanism step by step. The sum exceeds 255, generating a 9th bit that cannot be stored. Fourth, the time management matrix and context link. Connect it back to the scenario quickly and efficiently before moving to the next question. Therefore, the automated system calculates an incorrect value and fails. Master this flow and your mark potential shoots straight to 100%. Listen, error-aware notes are infinitely more useful than notes that only contain correct facts. This cheat sheet right here is your early warning radar for avoiding exam traps. Vague wording? You fix that by using precise technical vocabulary. Missing sequence steps? You fix that by explaining the mechanical process first and then the consequence. Stating an advantage with no reason? Always justify your choice within the specific scenario provided. This is exactly how you avoid the mistakes that sidelined Alex and Sam. By studying the mistakes of others, you are now fully equipped to navigate a hostile exam paper without triggering a single point deduction. If you can answer these 4 practical self-check questions out loud, your reasoning is completely locked in and you are 100% ready for deployment in the exam hall. Ask yourself right now, without looking at your notes, what exactly is binary overflow? How does it work down at the 8-bit register level? Where is it used, or rather, where does it critically impact real systems? And why is handling it correctly vital compared to just ignoring it? If you can speak these answers confidently, providing context and correct terminology, you haven't just memorized the source material, you've mastered it. I want to leave you with a provocative thought to test your newly acquired reasoning skills right now. If you were the examiner, what precise checklist would you design to grade an extended response question on binary addition and overflow? Become the examiner, and the exam becomes easy. Students who implement these computer science strategies see an average improvement of 2 full grade boundaries. But that only happens if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having the tactical advantage. Also, drop a comment below right now with your target grade for computer science and the biggest challenge you're currently facing. Our team reads and responds to every single comment. Like and share this video with a study partner who needs a rescue mission. Ace the Exams, your Cambridge success starts here. Until next time, agents, keep analyzing and keep explaining.